Look closely at the screen in front of you. You feel the glass, the casing, the weight of the device in your hands. Your brain registers it as a solid physical object. But physics tells us that matter is almost entirely empty space, held together by invisible forces. If we run the numbers on our own trajectory of technological progress, the odds that you are a biological creature holding a truly physical device in a base layer of reality are near zero. We are navigating a statistical architecture where the variables of our own survival point directly toward a digital origin. This is an audit of the data that suggests we are already inside a rendered environment. The structure of this argument was first codified in 2003 by philosopher Nick Bostrom at Oxford University. This graphic maps Bostrom's Trilemma, a framework with 3 possible evolutionary paths. The first path assumes the human species wipes itself out before reaching a technologically supreme post-human stage. The second suggests we reach that advanced stage but decide to never run simulations. Our current reality makes these first 2 paths difficult to justify. We are already pouring billions into high-fidelity virtual worlds and artificial intelligence. Unless our development hit a total permanent ceiling today, we are effectively proving that civilizations can and will reach the point of simulation. This leads to the bland indifference principle. If even a few civilizations reach this stage, they could run millions of simulations. Mathematically, for every 1 biological mind in a base reality, there would be millions of simulated ones. Statistically, you are likely part of the majority. With the first 2 options failing the test of our current progress, the investigation moves past the question of if we are simulated and begins looking at the mechanics of the code. To understand that code, we have to look past the user interface of our senses and examine the hardware required to run a universe. In 1967, computer pioneer Konrad Zuse proposed that the cosmos itself functions as a massive computing machine. This diagram illustrates Zuse's rechnende Raum, or computing space. It posits that space is a discrete pixelated grid. In this model, physical particles aren't stuff. They are just specific configurations of data moving across cellular automata. This suggests a program, but more recent work by David Wolpert at the Santa Fe Institute takes the logic a step further by removing the need for a host computer. Wolpert utilizes Kleen's second recursion theorem to show that a program can execute a perfect copy of itself. If Universe A simulates Universe B, and Universe B is a perfect copy, then Universe B can also simulate Universe A. The hierarchy collapses into a closed loop. Because information can be self-referential and recursive, there is no mathematical requirement for a physical base computer sitting in a higher dimension. Reality functions as code that sustains itself through its own logic. The self-simulation hypothesis, or SSH, builds on this by discarding the materialist view entirely, replacing hardware with mental information. Here, the universe is modeled as a strange loop, a mental construct that uses a mathematical code to bring itself into existence. The system operates on 2 distinct data types. In the emergent physical column, mathematical thoughts, geometry, and number render the pixels of spacetime. Emergent consciousness data handles the non-referential aspects of the simulation, the internal experience of humor, choice, and meaning. Within this framework, your observation is a functional requirement. By observing the world, you force quantum wave functions to collapse, essentially providing the system with the instructions it needs to render the next update. We are active components of the system, rendering the very reality we inhabit through the act of participation. Accepting that the physical world is an informational output forces us to reconsider the value of our own experiences. To navigate this, philosopher David Chalmers uses technology philosophy, applying these digital frameworks to find grounding in a simulated world. This is the it from bit principle. If a digital table is built from complex informational processes that allow it to function exactly like wood, it is functionally as real as any physical object. This framework also redefines our concept of a creator. A simulator acts as a system administrator, a natural being with vast technical power over this layer, but one who remains tethered to the laws of their own reality. The entire cosmos is a living, learning information system, evolving through the mathematical rules it sets for itself. Virtual reality is the only reality we have ever known. It is genuine, complex, and the foundation of everything we perceive as real. Once the nature of the system is clear, the objective changes. We are no longer looking for an exit. We are learning to program the reality we are already in.